to introduce you Antonella Cavazza, Associate Professor at the University of Parma, analytical chemist, but more than everything, a loyal user of the VELP OXITEST. But first of all, let me briefly introduce the topics of today, since we are going to cover very relevant topics, for example, circular economy, food waste and food loss, and how organizations, especially those operating in food, feed, but also in packaging industry, can contribute to the progress through specific strategies in order to counter food loss. We will also talk about oxidation stability and learn how to enhance industrial byproducts by using them for the development of an alternative packaging that we call active packaging. But let's start talking about oxidative stability and learning together what does it mean. The oxidative stability of fat could be defined as the resistance of fat through oxidation during the product shelf life. The oxidation stability is due to the chemical reaction that occurs between oxygen and some specific compounds of food. And this is one of the main reasons for food quality alteration and food loss, which can mainly cause unpleasant flavor and bad smell, a damage from an economical point of view, because of course you cannot sell this kind of product, and also a potential risk for the end customers. Of course, you may think that we are mainly talking about industries working in the food sector, but also cosmetic, pharmaceutical, and chemical industry may be interested in performing oxidation stability tests, because for labeling, for quality control and quality assurance, for research and development, for example, if you would like to optimize your product or create a new one and find the best formula, for human health assurance, but also in order to achieve, in some specific situation, legal compliance. But going deeper into the topic of today, let's talk about food waste. The numbers talk for themselves. 1/3 of the food produced on the planet is lost or wasted every year. And this number comes from the FAO from 2019. But there is an important difference that we should take into consideration. And this is the difference between food loss and food waste. When we talk about food loss, we are talking about the losses that occur in the first ring of the chain. I mean, during sowing, cultivation, harvesting, processing, storage, and in the first part of the agricultural processing. Here we are talking about 14% of loss. When we talk about food waste, we are talking about waste that occurs in the second part of the chain, which means during industrial processing, distribution, and also final consumption by humans. And here, nearly the 17% of food produced is wasted. This waste is mainly related to the loss of quality of this food. And as you can see from this slide, most of this waste comes from vegetable and fruits, around 30 and 50%. But we have, of course, also meat and dairy product, cereal, oilseed, and fish in the end. What is important for industry is that this wasted can have a new value, can have a new life, and we have to give them a new value, because this product, like we will see later with Antonella, tomato, artichoke, and many others, are rich in antioxidant compounds. And then they can play a key role because they can acquire a new value in terms of reuse, recycling, in order to minimize waste and wastefulness. But how, basically? We can use, for example, food waste to extend finished product shelf life, because as we say, they are rich in antioxidants, and so that could be used in the development on this finished product with a longer shelf life. But at the same time, as we will see in a few minutes, They can be also used for the development of a new kind of packaging that we call active packaging, where this antioxidant compound basically can contribute to the extension of the finished product shelf life, product that is contained in this particular type of packaging. This is very important because in so doing, we can of course extend the product shelf life, but at the same time, we can have a positive impact in terms of environment, economic point of view, but also social and ecological damage. And so now it's the time to learn how not to turn packaging into waste, but how to make waste becoming a new packaging. And for this session, I'm delighted to introduce to you Antonella, that will explain us some of the experiment and oxidation stability test she performed. And so let's discover more with her.
Good morning, everybody, and thank you for joining this seminar. I'm going to talk about this option, about using the natural substances from for obtaining a new kind of packaging. And I want to start with this image, and you can see that in nature we have many kind of great examples of perfect packaging. We can see example of biodegradable packaging, which is very resistant, so it can offer a mechanical protection to fruits. In many cases, this packaging has a very perfect design, and it's waterproof, can be edible, and it is also active. Active means that it contains inside the peel, for example, some antioxidant substances that can act to protect, for example, the fruit from UV length that can affect the stability of the fruit itself. So if we look at nature, we can take many good examples to design a new packaging. In this case, so we can think about using as a new source for packaging vegetables that are not considered suitable for commercial distribution. You know that many vegetables are discarded by the market because they have a size which is not good for selling, or is not accepted by consumers because of the shape or the ripeness grade. So all these vegetables have the same amount of good substances and nutritional value, but because of their shape and color or dimension, they are discarded. Another very important source could be all the byproducts that are obtained from the technological processes during food production. You see here an example of artichoke leaves that are not edible, but still full of important active substances. All of these sources are, of course, economic because they are usually discarded, and can be a great example of circular economy, which means to use again something which is normally thrown away to be inserted again in the productive cycle. The substances contained in byproducts, I show here some tomato and artichoke, are usually polyphenolic compounds, but in the case of artichoke, they also have prebiotic fibers that are important for their nutritional values, and other bioactive compounds. For example, in the tomato, we have cutin, which is a substance present in the peel outside the fruit. And it has a very lots of important features for being used as packaging. So we can obtain extracts from these vegetables that can be used directly as food additives to preserve deterioration of a food. And also the same extract can be added to a packaging, to a material, to obtain an active packaging. Then we could also make some edible packaging, so edible films, containing substances that can have a nutraceutical effect. And we can improve the mechanical properties of the film thanks to these substances such as the cutin, which is very elastic and waterproof. About what remains after extraction, it can also be a very good source because we have vegetable material like cellulosic and lignin that can act as fillers for materials in the case we want, for example, realize composite materials, or it can be just a material for bulk. In this slide, you can see all the different steps that we had to go through. I mean, we need to start with the drying process because the first thing is to avoid fermentation of the byproducts. Then we have to store them and evaluate their stability during storage. Then we have to set up all the conditions of extraction to have a good yield of extraction. And then there is the chemical characterization and the application, which is the realization of packaging. In all steps, we have also to check the safety assessment of these materials. About the setup of extraction conditions, we can check if the extracts are full of active substances using a classical spectrophotometric assay, for example. We here use a DPPH assay or the total phenol content made by the Follin-Chocolteau method. In this case, we could check the amount of active substances extracted using different solvent, different temperature, different time of contact, and we also could check if there was a difference between a traditional extraction or new technologies, or for example the ultrasound assisted extraction. But we realized that the best way to check the activity of the extracts on a real food product is to use the OXITEST, not the spectrophotometric assay. Why? Because in this case, we can add an extract to a model food and see which is the real effect on the food, which is not the same one that we evaluate by a chemical assay. But in this case, we can see the effectiveness on the stability of a food product. In this slide, you can see the induction period that is recorded by OXITEST. So we have a line, a curve, the oxidation curve, that shows us a value of oxygen pressure. Then at one point goes to low values because in that point, the green line, we had the induction period. So the moment when the oxidation of the product starts. So this induction period gives us a signal about the stability of the product. In this case, so we compared, for example, different tomato byproducts dried in a different temperature. In this graph, you see a yellow bar, which is a food model. In particular, it was sunflower oil alone, without any addition of extracts. And then in the blue bars are related to the sunflower oil additioned with the powder essiccated at 70 degrees. And the second blue bar is the same sunflower oil enriched with the powder dried at 40 degrees, so different temperature of essiccation. As you can see, both the blue bars are higher than the yellow one, so it means that the presence of the extract, it can give a gain in the induction period. And by comparing the two blue bars, we can see that the one dried at 7 degrees has a higher effect. So this is a way to check directly the effect on the product instead of checking the composition of the extract. Similarly, we did the same with artichoke, and we also performed a screening on different extract of different kinds of byproducts, like also the asparagus, the onion, and the grapeseed. As you can see, all of them here we have a graph comparing the different induction period obtained. In all cases, the vegetable oil alone has show the shortest induction period, whereas the grapeseed, for example, it has the strongest effects in prolong the induction period. So this is then the final realization of the packaging. So we incorporated into alginate film those extract. We also used some essential oils and tried different comparison with different substances. So you see different color, and also we obtained a different texture from using the different extracts. And we applied this kind of films on several kind of food products. In particular, here I show you different meat, hamburger, and then veal, horse, and beef meat. And we evaluated the effect on the meat by monitoring the color of the meat, which after even few days of storage in the fridge, it becomes darker and lose its redness. So with a colorimeter, we could check and measure the differences in the intensity of color to check its stability. And at the same time, we performed the analysis by OXITEST to compare the induction period of the untreated meat versus the treated one. And here on the right, you see the differences in the induction period, which is not very strong difference, but even a small difference can be traduced in prolonged storage, even of one more day, that for the groceries market is very important. I mean, it's already a good result. So then, finally, I want to underline the strength point of OXITEST compared to the classical chemical analysis. That it is a part that it is easy to use, and this automatic way, and everything is can be checked by software. But the main strength point is that the measures are performed on the whole product without any pretreatment, and we don't measure an extract which is limited to a category of compounds that have been extracted, but the measure is on the whole, on all the substances contained in the product. So in this way, we can evaluate together all the active compounds, and not only the compounds that are able to react with a specific reagent, as we do when we use the PPH or Foley-Chocotto method. In that case, we have a reagent that is able to recognize some chemical compounds, some functional groups, and maybe they don't take into account the presence of possible other antioxidants or possible pro-oxidants. And we know that the real stability of an entire food product is made because there are together many other substances in a matrix. So that if the matrix is complex, as usually is in a food product, we can have synergy between different antioxidants, or we have pro-oxidant and antioxidants. If we focalize on a category of compounds, then we lose this synergistic effect. And the only way to have a real and complete oxidative stability measure is this one that we use in OXITEST, because we put inside the plate the whole matrix without any treatment. So thank you, and there is Jessica now going on with the instrument features.
Thank you very much, Antonella, for this very interesting topic that you cover. Also for sharing with us your oxidation stability test and these interesting studies that you performed with the VELP OXITEST, oxidation stability reactor. What I would like to focus on is then when you hear about OXITEST, you are hearing about an official method that is worldwide recognized by this CD12C16 number that you see on this slide. So when you hear about OXITEST, you are hearing about a method, but at the same time also about this instrument that you now see next to me. This is basically an oxidation stability reactor that accelerates the oxidation stability, the oxidation process that typical in nature could last days, weeks, but also months. This is an oxidation stability reactor that accelerates this oxidation during the product shelf life and basically enable you to measure how the pressure inside these two independent chambers changed considering the oxygen consumed by the sample that is placed inside each one. This instrument can work with the solid, semi-solid, or liquid samples. And basically, the result that you obtain is the IP value that Antonella showed you before. The IP value is the induction period. So it's the time, it's the moment in which the oxidation stability, the oxidation basically starts. And so this means that the longer the IP, the longer the product shelf life, of course. Now, we are pretty much at the end of this event, of this lab spotlight. We are available, of course, to give you more details, so don't hesitate to get in touch with our expert. We will be delighted to give you all the details and information you need about the VELP oxidation stability reactor.